Okay, so we throw a ball up at 5 meters a second at 37 degrees. Anytime you see an angle, you should break that up into components. Okay, so to calculate this, think, are we going to use sine or cosine? Side's going to be sine, and I designed this to be a 3, 4, 5 triangle. To find this side, we're going to use cosine. You find that to be 4. So now the question is this 3, is this how high it goes, or is this how fast it's going in the vertical direction? To answer that, the unit of this will always be the units of these. These are the components of this one. These two make up this one. So this has to be consistent. So this is your how fast you're going in the vertical direction. All right, back with me. The 4, is that half the distance that it travels horizontally, or is that how fast it's going horizontally? Okay, again, how fast. It's in meters per second. It's not in meters, it's in meters per second. This is your initial horizontal velocity. Okay, what I just talked you through, is this the height? Is this half the distance? Those are popular pitfalls that I see students fall into. Don't fall into that. Everybody understand that every side of the triangle has to be the same measurement, has to have the same unit. Okay. Now, a follow-up to that is this 3 meters a second as the ball is in the air. Does this change, or does it remain constant, the 3 meters a second? Tell your neighbor. Is this 3 meters a second in the vertical direction, does that stay constant, or does that change? Changes. Slows down and then speeds back up. In the horizontal direction, is this 4 meters a second? Does it change, or does it stay constant? In the horizontal direction, velocity remains constant. There are no forces acting on it in the horizontal direction, therefore it's going to do what inertia wants to do, and that is maintain that 4 meters a second. Good with that? Okay, give this one a shot. Have a conversation.
Yeah, but it's still not the same speed.
Right, but it's still the result.
Correct answer is B. Beautiful butterflies. Okay. So vertically, how fast is it going at the highest point? 0. What is it doing horizontally? It's maintaining whatever speed it had right here horizontally, whole entire time. Okay. So when I say overall, what I'm talking about is both horizontal and vertical. Okay. Good with that. Next question. Tell your neighbor. Tell your neighbor why.
Because the other one is goes up and at some point it's going to hit zero velocity on that line. While the other one's already.
Okay. In order to be the same, well, what is the correct answer? B. In order to be the same, you need to throw this horizontally. That was a bad throw. Anyway, you have to throw it horizontally in order to have it hit the same time. This is being thrown vertically. Okay, this would be the same thing, the exact same question as, hey, which is going to hit the ground first? Does that make sense? Okay, exact same scenario, except the one thrown is moving horizontally. Okay, so what I'm trying to break you from is like, oh, it's always the same time. Like, no. If you throw it horizontally, it is, but it's not if you throw it up at an angle. Okay, good with that? All right. Ball is thrown at 30 meters a second at 20 degrees. What should you do first? Let me tell you. You should draw 2 diagrams. First is the trajectory. Okay. This, you're going to use that to show displacement. Okay. The second one is your draw your velocity vector, your initial velocity vector. Nope. There's 20 right there. Okay. Anytime that you see an angle, you should think, I should probably break that up into components. So go ahead and do so. Calculate the components. Beat me to the answer. How are we doing? You get it? Okay. Next step is to define your variables. Put them in the chart. So identify as many variables as you possibly can for this given scenario. So while you're doing this, I have a follow-up question. Which side, horizontal or vertical, does the 30 meters a second go in? Is that going purely in the horizontal direction? Is that going purely in the vertical direction? No. This number will not find itself in this chart, nor in any equation that you pick. I don't care how desperate you are, this does not go in to this chart or an equation. You use this to find these. Okay? How are we doing so far? Okay. Some people like doing this. I'm fine with it. This isn't necessarily my preference, but whatever. They say initial is horizontal velocity is 28.2 meters a second, and your final horizontal velocity is still 28.2 meters per second. Your acceleration in your horizontal direction is equal to 0. I kind of capture all that with this, the idea that it's a constant 28.2 meters a second in the horizontal direction. But if you like this, that's totally fine. Okay. In order to find time, how long is the ball in the air? If I try to find time using this, all I'm going to find is 0 equals 0. Okay. So I need to find one more piece of information. I need to define or discern one more piece of information for the vertical direction. Okay. Specifically, your final vertical velocity. There's actually 3 different ways to do this. 2 ways are more popular. I'm going to recommend one of those 2 popular ways over the other one. both employ fun facts of free fall. How does the velocity, vertical velocity here, compared to the vertical velocity here? Emma? Yes, the same but negative. This, I would recommend doing this approach. Okay. The alternative, which is dangerous, legal but dangerous, is to say the final is here, because what do you know happens at the highest point? It stops vertically. So your final vertical velocity is 0. However, that only took half the time to get up to here. You would then have to double it, and that's where people get tripped up. This approach is just the whole thing. You don't have to remember that. Okay. So pick an equation and beat me to the answer. Hopefully you picked this equation. And then modified that, tweak that a little bit for the vertical. So you have a negative 10.3 meters per second is equal to a positive 10.3 meters per second plus negative 9.8 meters per second squared, delta t. And that would be 2.1 seconds. How do we do? Okay. Follow-up question. Any points of confusion before we move on? Questions. So the follow-up question is, given the same scenario, what is the range? When I say range, that might be a little confusing with math class. Math class, the range is y. Here, it's horizontal displacement. Think of a driving range or a golf range. Like, how far can you hit it? So what we're looking for when it says range is your horizontal displacement. Okay. So I'm looking for this. See if you can beat me to the answer. My recommendation would be to recognize you're moving at a constant velocity, 28.2 meters per second is equal to displacement over 2.1 seconds. And you'd find that to be like 59, 50 something or other. 59.2 meters. Okay. You could have also used, with all this information, you could have also used this equation. So you would stick in 28.2 plus 28.2 because it's constant, and then divide it by 2, which is 28.2 multiplied by 2.1 seconds. Or you could use this equation, and recognize your acceleration is equal to 0, and that knocks that out, so you have 28.2 times 2.1 seconds. Anyway, it's fine. That's my preference, but okay. Sound good? You got a worksheet due on Monday. You know how to do it all. So if you don't want homework over the weekend, pretend like it's due tomorrow.